Good afternoon. Welcome to the inaugural session of this course, Environmental Engineering. So, in this course, in the coming lectures, we are going to discuss various topics, which includes what is the necessity of water, what are the various types of water demands, then what is the important to be protect the water source. Then the entire syllabus is divided into water supply and as well as various distribution systems. Then whatever the water we received from the water supply agencies, after that, after using the same water, how we are treating. So in this particular topic, I'm going to deliver my lecture in this water quality and demand and as well as supply. Let me introduce myself first. I am Madhusudhan Reddy, working as assistant professor in the Department of Civil Engineering, Institute of Aeronautical Engineering. And coming to the, as we all of you know that water is a source of life, and you can see here the water is very fundamental to the life. So without water we are not supposed to live. Suppose for example, if you take another component, that is air. So air is available anywhere. Maybe there may be a difference in quality, but it is available. Coming to the food also available, but it varies some quality. So without this water, we cannot survive. Even without food also we can survive some couple of days, but without water we can't survive. So for that, so how we will see that the today's reality. This is the data up to 2017. So from the United Nation. So they, according to their point of view, 785 millions people remains without water. 785 millions of people remains without water for even for the basic drinking water. So these data up to 2017. So here you can see in another parameter, 2 out of 5 people in the world do not have a basic hand washing purposes the water. So hand washing facility also, 2 out of 5 people they don't have the water. So whereas you can see in this case, 1 out of 4 1 out of 4 uh, 1 out of 4 healthcare facilities worldwide they are facing a lot of problem with this water water quantity. So you can observe here what is the demand, and we can observe why that water is important, and why we need to protect the water for the future. So as the basic you can see how we will get the water. So there you can see this is the entire process. This is the entire process. The first from the ocean the water, the first step is the water is evaporate, and then after from the trees it is transported and then stored in the clouds. Then after precipitation, the water will the water will flow in different way. First it's percolate into the ground surface. Then then after that, then the water start the flowing. This is we call in technical words, we can call it as runoff. Then the percolated water may store like groundwater and then springs in wells. So like you can see here, this water finally it merges into the again ocean. This is a continuous process. And in this way only we will get the water in the ground. Water will be stored in the ground, and then sometime in wells also. So what are the basic problems and as well as challenges we usually face with the water? The first and foremost problem is water availability and quality. Water availability and as well as quality. So here, as we discussed in the previous slide, till 2017, there is a lack of what 2% out of 4 facing the problem even for the hand wash purposes. So here, so this quality also another most important parameter. So then whatever the water is available, what is the quality, whether we can use for the drinking purpose, so this is depending upon the quality of the water. So then the another most important challenge and the problem is water quantity. So here very particularly mentioned the water quantity. So this is the water scarcity is depending upon this population quantity. For example, in any city, if you consider any city which having the population more than 1 million or 2 million, we supposed to supply that much of quantity in order to reach their demands. So that's why here the water quality is very important. So uh, then population, as I told in this just now about the population. So this population is very one of the major parameter to be considered while uh, while estimating the water for the future needs. So this the here we need to estimate the population in future years, that we simply called as population forecasting studies. There are various methods are there to calculate this population forecast for 2050 3000 year, like that. So we have different methods. We'll see all those methods in coming lectures, then how to get the population for 2030 2040 2050, like that. So then another important challenging in this water supply system is industrial growth and as well as urbanization. So industry growth, we as we observing the industry, India is one of the developing country that most of the industries got set up in last 2 decades. So here the urbanization is also become improving due to the migration of the people from the rural areas. So in order to reach uh, their requirement, we need to supply adequate water facility towards industry proper operation. So then climate change. So this is one of the major another important challenge point in this water supply point of view. The climate is sometimes draft may occur due to some any reason. So in that case the water demand may increases. So the ground, due to the lack of rains, the groundwater levels are also become reduces, and again there will be a problem for the minimum drinking purposes. So then for another most important challenging point in this water point of view, it is water management and as well as governance. So water management. So here for example, if we are supplying uh, for any metropolitan city. So for example, according to our calculation, we will get some x value. This is for LPCD, liters per capita per day. LPCD is nothing but liters per capita per day. So this much of quantity of water we need to supply in terms of, may say for example, liters. So here, so we usually design our storage system, pipeline system in order to supply this much of quantity of water. But if there is no proper management, so we this number becomes increases, because this management point of view, we supposed to take care of leakages. We supposed to take care of the leakages and some sudden problems in the laid pipeline. So that's why this management is also one of the important parameter. Then we can, if you do manage properly, then we will supply the water in adequate manner in order to reach their public demands. So the various contents now in this lecture we are going to discuss is protected water supply. So why we need to protect the water supply, that we need to be we are going to be discussing these lectures. And then population forecast. There are various methods I told just now. Those methods in detail we will discuss, and we'll do some problem calculations. And design period. So this design period for years, for example, for the next 30 years, like that. So then water demand. In this we will discuss about what are the various types of demands. Then how to calculate, how to estimate that water according to that demand in order to reach these future needs. So then types of demands, continuation to this one. And then factors affecting the fluctuations in this demand may be vary, that we call simply fluctuation. And what are the various factors affecting that fluctuations we will discuss. And then the another type, another demand also will discuss, that is the type of the demand. So then the first question, why we are here. For example, if you talk why we are discussing these particular topics, I mean water supply and as well as water protected water supply. So here we all acknowledge that the people in many parts of India are facing challenge with too little and too polluted water. So we in especially in India, due to the vast area covered with a uh, rural area, so there the people are facing too little water supply, and as well as even though that little supply water also got polluted. So then in order to reach their point of view, uh, in order to make the quality, and we need to avoid the people to do not the waste of water. That is also one of the major objective of this particular topic. So that's why we are here, to in order to know what is the importance of the water, why and how to motivate the people uh, to not to waste the water. So then we are willing to contribute to society for resolving the least part of these challenges. So various challenges whatever those discussed, in order to minimize those challenges, we are here to discuss that also, in a way to uh, motivate the people towards not to waste the water. So then how we can help them, how we can achieve those challenges by judicious supply and uses, and then protection of the resources, whatever the resource that's infiltration galleries, or whatever the source of water that we need to be protected for properly in order to supply the water for the future effectively. Then effective and efficient management is required, as we can. So if you implement this effective and efficient management for the laid pipeline or the laid construct existed reservoir, then uh, we can store the water for, we can supply the water. We can at the same time we uh, we will supply the water for the future demands, and then finally we will make all the people for being a responsible. This leads to they should not waste the water. So acquire the awareness and knowledge about water source, then schedule demands and the availability supply system, and as well as governance. So here the present status, if you see, this status is this is very latest data. So coming to this data related to Indian, the status of the tap water supply in rural, especially this is a tap water supply status in a rural homes. So here total total number of households, so this number, and then households with the tap water connections as of 15th August 2019, it is around 16.75% only. And then households with the tap water connection as on date, this is this data recent one, till the March 2022 2022. So this is only 47.97% of people with the water connection till March 2022. So this we can see, since launch of this mission, the government has launched the mission is called Jal Jeevan Mission, and after launching this mission, these 31.21% of households got provided with the water quality water supply. So then continuation to the previous slide, it is again present status. From this you can see, you will get this data from the Jal Jeevan Mission. In 31 months since 2019, 6 crores rural households got tap water under the Jal Jeevan Mission. This from the last, from the last 31 months, totally 6 crores of people in rural Indian people got their tap water uh, under this uh, under this mission. So, and you can see the tap water supply in households. So there we can see various entire India. This data is till 2022 March 25th, very latest data only. So here you can see the percentage of households got tap water state wise. You can see, if you talk about the Telangana, it is around it is in the range of Telangana, it is in the range of 100% of people households getting their water through tap. And then similarly you can see uh, Andhra Pradesh, and it is in the range of uh, 76 to 80. And then Karnataka, you can see around it is only 26 to 50% of people are getting the water through the taps. So this is mission, and then you can see many states, MP and other states, you can see only 11 to 25% of their state people are getting the water through taps. So these are very latest data only. So we can understand how much important of the water. uh, so see, many of the, if you talk about only few cities, this one and as well as Telangana, and no more. So on these two states getting 100%. These two states people are getting on 100% of water through a tap, each and rural and as well as urbanization. So rest of the cities in India and rest of the states in India, they're still supplying the water. So they need to supply more. Over time, God grace, we don't 0%. No state in this 0 to 10%. So minimum they are getting the water. So here we are supplying the water, but we don't know how much it is quality. So that is also one of the challenge. Whatever the water we are supplying, we need to ensure that it must be a quality one. So in order to check the quality, there are various methods that we'll discuss in the coming lectures. So we are going to also discuss about what are the various water treatment procedures, and then how to improve the quality. So we are talking about the various challenges. So in that first challenges, we can say the water demand. So then these water demand, how much water is to extract from the source. So whatever the source, maybe a well or maybe infiltration gallery. So from that, how much water you need to extract. So these quantities depending upon the population. So this quantity is depending upon the population and other demands. For example, you can say the fire demand and industry purposes, and residential purposes. So on different demands are there, and this how much quantity of water to be extracted from the source is depending upon the various demands, and then population of the city, and some other factors. So then source. So coming to the source, so what are the various sources are available that need to be discussed. And then water intake, how to withdraw a water from the source. So once suppose if you take a well, so then how to extract the water from the well, that is also one of the major important topic to be discussed here. And then quality, so we need to improve the quality, and then what are the various treatments are required in order to improve the quality, that also we'll discuss in coming lectures. So the spread of the users, where to distribute, and as well as how to distribute. So these once after getting the water, once after extracting the water from the source, so then usually we lay some distribution system. Then how to distribute, in what way we are distributing, where to distribute, that we should know before only. Then only we will get we will satisfy the water management and as well as governance. Now, coming to the protected water supply, as we are discussing, water to be protected, whatever the source also to be protected. So, coming to the protected water supply, the definition you can see here, the water source protection means protecting from the contamination, and overuse at the source. Especially, this is overuse at the source, and both water quality and quantity we drink and use, thus reducing the risk to public health from the exposure to the contaminated water. So whatever the source, for example, if you say this is a well, uh, this is a well, there is a there is a source. This we call it as a source, and this source must be protected from the contamination, and at the same time this the overuse at the point, at the source point also will need to be reduced. And then finally we will achieve this target. We can protect somewhat so we will protect the water source also. So then objectives of protective water supply, you can see to supply safe and as well as wholesome water to the consumers is one of the objective, and another objective is to supply water in sufficient quantities. So sufficient quantities nothing but in our we will cover we in this according to this point of view, we need to supply the water in a sufficient manner in order to reach the public residential needs, industry needs, and as well as institutional needs, hospital needs, and then fire demand, so and then agriculture demand. So in order to reach these various demands, we supposed to supply. This is one of the main objective of this water supply system. We supposed to supply the water in sufficient quantity, then only we will reach their demands. So then the another major objective of this one is to supply the water at convenient points and as well as timings. So why this point is very important in this case? In India, the rural people usually go to different places for work purposes. So if you supply the water in the midday, so the wastage become more. So in order to avoid that kind of problems, we usually stick on to the timings where at which time we can reduce the wastage of the water. That is also one of the important parameter. So then once if you to in order to satisfy this particular objective, we supposed to supply the water in a convenient and as well as in a convenient timings, then we can reduce the losses of the water. So then to supply the water in a reasonable cost to the users. So this is also one of the important. This is directly affect the people's economy, and then to encourage the personal and as well as households cleanness of the users, then we can improve the somewhat water quantity. Water quantity. People generally use water for 2 to 3 days once after storing. Then one without cleanness, that water get polluted. There may be choices for the quality becomes polluted. So in order to make this quality, we need to encourage the people to keep their surroundings and their house very clean. So then components of protected water supply. So we are discussing about the protected water supply. Coming to the components of this protected water supply are, you can see here the raw source of water. The various sources of water can be classified into two categories. One is surface and as well as subsurface. So protected water supply nothing but here we are going to discussing about source point. That source on for this source only we supposed to give some protection. So these raw sources are surface and as well as subsurface. So coming to the surface, there are few things. One is ponds, lakes, streams and rivers, and storage reservoirs and ocean. Generally not these are the main used for the drinking purpose, and another is the source, that is ocean, generally not used for the water supply and at present. So some advanced the countries like Dubai and there the people usually collect the water from the oceans, then they do then do apply some proper treatment, then they use same water for the drinking purpose and as well as the agricultural purpose. So this is also these are the various sources are the surface sources. So coming to the subsurface sources are springs and as well as infiltration wells and the tube wells. These are the subsurface sources. So here there is a lot of problem we'll face with while protecting only with the surface water. This not required the particular protection methodology, and the surface water, because it is open to the atmospheric, we need to be protect this from the contamination. So that is also one of the challenging and as well as objective in water supply system. We need to be protect these water sources. So coming to the next slide is, in this way, what are the various methods? Conventional as well as non-conventional. So this is you can see whatever we discussed in the previous slide about the surface source. So it comes under the conventional, and this is subsurface. So sorry, and you can see this surface is again same rivers, lakes, and canals, and as well as ponds. And groundwater is groundwater usually with this chemicals like fluoride, nitrates, and some iron also included in the water. Then the quality is depending upon various contamination and presence in the water. So then rainwater. So then non-conventional, coming to the non-conventional is harvested rainwater, stormwater, and reclaimed water, and then seawater is a non-conventional. So the seawater is required desalination, desalination as well as proper transport in order to reach the uh, point where we want to supply. So again, you can see the term protected water supply is refers to water that has been treated to remove impurities and as well as made safe for consumption by the general public. So water may be polluted by the physical or bacterial agents. That's why we need to be give the protection to the source. So then we can able to supply the water without any impurities. Like we can supply the water some quality water. So need of estimation of water demand. So this is the in this particular lecture we are discussing completely basic. I mean various sources we are discussed, and then why we need to protect, what is meant by the protect, then what are the various challenges that we are facing while supplying the water, then what is the need of then coming to this topic is what is the need of estimating of the water. So as we know, without this water we can't live. Even couple of days we can live without food also, but without water we can't live. So here then uh, some adequate in order to supply some adequate required quantity, we supposed to estimate the demand. So as I said, while estimating the demand, we need to be consider various parameters. Those are residential purposes, fire demand, industry demand, and as well as institutional demand, and as well as hospitality point of view, and then the fire demand already discussed, and agricultural purposes. So in order to supply the water, we need to estimate we need to estimate. So that's why we usually discuss about this need of water demand estimating. So water services are usually established in advance for future. So the kind of infrastructure and setup needed will depends upon the water demand to be supplied. So whatever the infrastructure we usually arrange for supplying, is depending upon is actually designed in order to fulfill the future demand. So that's why we need to estimate the future population and future water requires. So then this infrastructure includes pumping powers, reservoir capacity, pipes size, treatment, and as well as plant capacity. So in all the way, once if you are ready with this infrastructure in order to reach the future demand, so while constructing these pipe sizes and a treatment plant, we supposed to estimate the future demand. We supposed to estimate the demand. So, for example, if you are supplying one like in for a small town, for a small town, uh, 3 lakhs of liters water per day, so we'll get same water we'll get the for treatment purpose. So then while constructing a treatment plant, we while designing a various chambers in the treatment plant, we supposed to know how much wastewater we are getting from the households. So this is also one of the major important pattern uh, thing. That's why we need to estimate the water. So then you can see, if you are not properly estimated, it means if you are not considered the future growth in all the cases, in that case, so it nothing but underestimation. So underestimation leads to inadequate design, whereas overestimation also leads to uneconomical and as well as inefficient water system. So then, for example, if you are not estimated properly by considering all the different various types of demand, so then uh, we will confuse by designing the pipe of the size while designing the treatment plant, and as well as while arranging the required pumping setup. So this underestimation is affect the design, and as well as whereas overestimation results in the economical and as well as insufficient water system. So then, so therefore, it is important to estimate the water demand to the best of accuracy possible for the life period. So then for the life period of the various projects. So that's why I think you understood the water need of estimating the water demand. So in order to arrange these infrastructures, these various infrastructure, we need to be estimate the water demand. Then we will design the storage tanks, pipes, and the treatment plant. So if you underestimate the demand, then it leads to the problem in in the design, and if it is overestimated, it is become economical. So then concepts for estimation of the domestic water. So in detail we'll discuss in the coming lectures. So the concepts, the overall I'm giving here in this particular inaugural session. So the concepts of estimation of domestic water is the quantity of water required to domestic activity depends upon that to be considered here. So this per consumption rate, this is per capita demand in liters per day per head. So per capita per day per head. So that need to be considered, and total population to be served at the end of the design period. So this is a design period. For example, it may be some years, it may be some years. So at the end of the design, so we need to supply entire water to these people, total population to be served. That's why the population to be considered. For example, if I am calculating, if I'm constructing a water storage system in order to reach the public needs in 2030, so as we know, the population become increases. So in order to reach this demands in 2030, for that I need to estimate the population forecast in 2030. So then I can arrange the infrastructure. Then I can design this so design pipes and as well as water treatment plant in order to reach the 2030, in order to reach the people needs in 2030. So then quantity is required. Once if you get the number of people, expected number of people and households in 2030, then the per capita, once after getting this per capita, for example, it is actually 135 liters according to the codes, 135 liters per capita. So then this is the total population. This population will get from the population forecasting studies. So in 2030 we are calculating. So then for 2030 related, we need to do the population forecasting. There are different methods that we'll discuss in the coming slides. So once after getting the population in 2030, then if you apply the same population for the per capita, we will get the quantity of water. Then according to the quantity, we will able to we'll get the details. Then we can supply the adequate water in order to we can reach their demands. So then additional demands such as firefighting, institutional industry needs and losses are to be considered. Then if we have proper management, then we can reduce the loss some extent percentage to some 10% or 5% like that. But if without proper management, it is not possible to avoid these various losses. So that's why the proper management is required in this case. And water requirements are never constant. These requirements are never constant. The various reasons are there for fluctuating the water demand. So as for example, if you take in 24 hours of one day, means 24 hours, usually you consider only two parameters. One is residential purposes and the second one is the industry purposes. So in these 24 hours, morning, basically from morning, people usually hurry to reach their offices and their working places. So that's why the water usage is more, and for their personal things also they use water. And then in case of residential, the peak hours we can say 6 to 10 a.m. And after 10 a.m. usually the offices and working hours will start. This is from consider from 10 a.m. to 4 or 6 p.m. So then after this time, afterwards, then again the demand may increase in case of residential compared to the industry. So that's why here it is water requirements are never constants here. So this is we can call it as fluctuations in the demand. So the requirements may sometimes may increase suddenly. So in the especially in cases of festival times, and some other cases the water demand somewhat increase suddenly, so that to be managed while designing all those setup infrastructure. So the fluctuations and as well as variations in water demand must be given a due consideration while designing a infrastructure, and then only we can uh, then only we can supply the water uh, supply the water for the people in order to reach their requirements. So with this, I am closing today's lecture. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.